Those that use our website, I don't know if I've got it on here or not, but it's plants.ifas.ufl.edu. HTTP, I guess. But we got hacked in October, and we got butchered bad. And why they do it, I don't know. But we're finally getting back up and running kind of like we used to have. All right, this calibration set, you've got the problems in front of you. And what we're going to do is go through some of these problems slowly. And we're going to try and make sure that those of you who might be taking an aquatics exam real soon can get most of these questions right, because calibration is a very important part of what we do. As Dr. McDonald's talk would indicate, that we put a lot of research into herbicides, how they work, where we can use them, aquatic registrations and the different registrations. And industry does a lot of work as well. They spend millions of dollars registering these products, but you folks are the end users. You're the people that can kill these products and create real problems. So make sure you read the label and follow all directions. And make sure you've got the right label, because we have some products that are registered for terrestrial use and some that are in aquatic use and things like that. All right, let's talk about calibration. It scares the death out of everybody because it's mathematics. It just seems to bother people. But it's really simple. You just got to break it down. Lynn, do you think we could shut the front off maybe so you can see it better in the back? There's some lights right over here. All right, remember. All right, and this is all you've got to remember. All you got to have to calibrate anything. It doesn't matter if it's a train on a railroad track. It doesn't matter if it's a backpack sprayer, a truck-mounted sprayer, or a boat-mounted sprayer. You got to have three things to calibrate. Gallons per minute output. How much material are you putting out in every minute? That's number one. All right. Number two is swath width. How wide a swath am I spraying? Will my handgun reach from here to the wall? Or will my handgun reach from here to the back wall, 100 feet or 25, 30, 40 feet? That's the swath width. All right? And then you can calculate your speed. Now, these are generally very similar. You're not going to change your swath width of your handgun much. And your gallons per minute are generally going to be the same. So you really vary your speed. But these are the things, there are only three things you need to calibrate anything that's out there. So let's go through some problems here. First problem we got is it's a canal. And the number one thing you do, and you heard it in grade school and in middle school and in high school and in college, and you'll hear it again. Read the question, all right, very carefully. Joe Gator wants to spray water hyacinths. These are emergent plants. It's going to be a foliar spray in a canal that is 2.5 miles long, 30 feet wide. What is the area of the canal to be treated in acres? All right, that's pretty easy. There's one thing you got to do in there. All right, the area of a rectangle, all right, is length times width. So the first thing you do is you got to get the answer in acres, and we know that the acre is 43,560 square feet. Good numbers to know, by the way. 43,560 square feet an acre. First thing you got to do is you got to get everything in feet. So how many feet in a mile? All right. So you multiply 2.5 times 5,280, and it gives you 13,200 feet long. That canal is 13,200 feet long. How wide is it? 30 feet. So now to get the area, you do what? Multiply length times width. So 30 feet wide, 13,000 is 396,000 square feet. All right. The question, though, is let's read the question. What's the area of the canal to be treated in acres? Now, if you're taking a pesticide exam, they're going to have in there 39,000 or 396,000 square feet as an answer. But it's the wrong answer, all right? It's correct in the fact that the square footage is there, but the question asks you acres. So how do you get to acres? Divide it by 43,560. So 396,000 divided by 43,560 gives you 9.09 acres. Now, you don't worry when you take the exam. The answers are going to be different enough that, you know, a few tenths isn't going to make much difference. So I believe the answer probably would be 9.1, the correct answer on a multiple choice exam. All right. To determine acres, you must get all units in square feet. since we use the basic area of an acre of 43,560 as the square feet in an acre. So that's pretty simple. That's really easy. And if you do happen to take an exam, I don't care what exam it is, you get to something that looks difficult, just move on. And this talk today will start from the very easy and get up more and more difficult. All right, you ready for another one? Any questions on that past one? Piece of cake. All right. So this canal is 2.5 miles long, 30 feet wide. We already figured it out. Once Gator gets to the canal, he realizes that his truck-mounted sprayer up there can only spray about 10 feet on each side of the canal. And that infers that you're going to treat both sides of the canal. So you do 10 feet on this side of the canal, you do 10 feet on this side of the canal, and the canal is 30 feet wide, so must be there's a 10-foot strip in the middle. All right. So now, with this information, what will be his actual area treated in acres? You can do it in your head, can't you? Yeah, it's 2/3 of 9.1. All right, but let's not do it that way. Let's do the calculation as more practice. It's about the same, okay? He's only doing 10 feet, so think about it. How many acres will Gator treat if he treats only one side of a canal? Well, that'd be 1/3 of what the canal area is, or about 3 acres. So you can estimate what the answer is going to be. So if you do the calculations and you come up with 30 acres, well, mercy sakes, you only got 9 acres in the canal, so 30 acres must be wrong. So think as you go, all right? Let's do it right. 2.5 miles times 5,280 feet a mile, still 13,200 feet long, times 10 feet wide is 132,000 square feet. How do you get that in acres? Divide by 43,560 is 3.03 acres treated on each side. Okay? But you're not done with the answer, and I'll guarantee you that 3 is probably one of the answers in the multiple choice questions, but you're going to treat each side. So after you get your answer, read the question again. He's going to treat both sides of that canal, which is actual area in acres, so you multiply each one side, or each 10-foot strip, twice, because we did both sides of the canal, and you're going to end up with 6.06 acres. And the answer, I think, is going to be probably 6. A little bit different. On his way home, Gator passes by a lake, a real circular lake. It's in North Florida. And what is the surface area of this circular lake in acres? 1.7 miles across. All right. The exam booklet has these formulas in it, the area of a circle and things like that, and because people just don't remember those if they don't use them regularly. So the exam booklet has many of these things in it. But it's good to know some of these, all right? Just like the first questions with the canals, if they ever give you something in miles or yards, convert it into square feet, because everything we do is based on an acre. All right, so that's one thing there. So let's get it. You got to get this 1.7 miles across, convert it to square feet, convert into square feet to get your acres. Well, you got a formula to do that with. Let's first of all get the diameter. That's important. We're looking for the radius when we get there. 1.75 miles times 5,280. You've already done that. The feet in a mile gives you something like 9,240 feet across that lake. Pretty big lake. Area of a circle, pi r squared. All right. You do everything in the parentheses first, if you remember algebra. So what's the radius? We don't have a radius, do we? All right. What do we have? The diameter. The diameter, what is the radius? 1/2 the diameter, that's right. So that's what we need to do. First thing, radius is 1/2 of the diameter, so you divide it by 2 to get your square feet. Or it's not square feet, feet. Pretty easy to get square feet and feet all mixed up. I'll try to keep it sorted out. So your 4,620 feet is the radius. It's 1/2 the distance across the lake. So area equals pi r squared, okay? R squared is r times r. So 4,620 times 4,620 is 21,344,000 square feet. Million square feet or something like that. That's a lot of them, 21 million square feet. All right? So if you divide that by 43,560, have you got it? No. Look at the formula. You got to multiply it. Area of that circle or that lake is 3.14. That's pi. That's a constant times the r squared. All right. So now you get 67 million square feet. But now that's the area in square feet. So how do you get acres? Divide it by 43,560. Right. Okay. Just got to get miles into feet because that's what you're dealing with on all of these exams. All right, so it turns out it's 1,538.6 acres. Questions? I can back up if necessary. You seem to be getting it. Good. All right, do something a little bit different now. Gator's housing division development, there's a rectangular pond, 780 feet wide and 1,450 feet long. An average depth of 6 feet. How many acre feet? All right, well, first thing you got to do is just how many acre feet. What is an acre foot? It's 1 acre in aquatics, 1 foot deep. So it's basically 43,560 cubic feet in an acre foot. So first thing you got to do is you got to get acres. All right, so what do? I'll bet you multiply the length times width, get the area in acres. So 780 times 1,450 gives you a little over 1 million square feet. All right, divided by square feet an acre, and you end up with 25.96 acres or 26 acres. All right, is that the answer you're going to check? Nope. How deep's the lake? All right, the average depth is 6 feet. So if somebody went out there with a pole or an anchor or a line, or if you're real fancy, you go out with a fathometer or whatever you wanted to do it, and you take 10 or 20 samples both ways of that pond, and you get an average depth. All right. Some places it might be 8 feet deep, other places it might be 4 feet deep, and there's different ways to do this. But hey, it's just enough to go out there and get a good average feel. All right. If you're off by an acre foot or two, it doesn't matter because most people are using the low end of the range for treatments, for submerged weed treatments, or in the middle range. Very rarely do we use a maximum registered pesticide rate in aquatic weed control. Pretty rare that we do that. All right, so if it's an average foot, if those 26 acres average 6 feet deep, all right, what's the acre feet in the lake? 6 times 26, all right? 6 feet deep times 26 acres is 156 acre feet. All right, pretty easy. That's the volume of that lake in acre feet. It's not going to ask you in gallons. We could calculate that too. We could even calculate milliliters. We could calculate anything based on that because we know the volume of that lake. That's how much water is in it. All right, we'll get back to some more of that a little bit later. Gator's got a new 14-foot fiberglass airboat. The tank on his new boat is 300 gallons, and he's applying 40 gallons of solution per acre. All right, he's already done his speed calculation. He knows his swath width, and he knows he's putting out 40 gallons per acre. All right, 40 gallons of solution per acre. Question, how many acres can Gator treat per tank? In other words, he mixes up his tank with 290 gallons of water. He puts in 6 gallons of a herbicide, and he puts in 4 gallons of surfactant for a total volume of 300 gallons. Goes out in the boat, he knows what his swath width is, he knows what speed he needs to go, and he's going to put on 40 gallons per acre. So how many acres can he treat with that tank mix if he's doing 40 gallons per acre and he's filled his 300-gallon tank up? What do you do? Pretty easy. This is a gimme. All right. 300 gallons of tank mix and spraying 40 gallons per acre is simply divide the tank volume that you've made, and you then divide by 40, and you get 7.5 acres. What if you've only got 7 acres to spray? You only make up 280 gallons of spray mix. All right. So you're thinking about that. All right, these values, they're going to be in They're going to be in the exam booklet when you take it. 128 fluid ounces per gallon, 4 quarts per gallon. There's 8 pints in a gallon. Feet per mile, we've already done. Square feet per acre. All of these are provided, but they're nice to know. And if you're going to calibrate equipment and use stuff on a regular basis, and if an FDAX inspector comes by and starts asking you questions, you know, and he says, hey, how many ounces of that? You know, I used 2.2 gallons. Well, how many ounces in 2.2 gallons? Gee, I don't know. I just measured it here in my cup. Well, that'll get you away. But if you happen to say 128 ounces per gallon, he's going to say, the guy might know, that guy or gal may know what they're talking about. So it's the impression you leave people. So be professional. All right. Think about this one. Bonus question. If you want to apply 2 quarts per acre of herbicide with that previous system, all right, and you're going to do 7.5 acres, how much herbicide do you put in the tank? You're going to use 2 quarts per acre, and you're going to treat 7.5 acres. How much herbicide put in? Somebody yell it out. 15. All right. All right. The question is, how much herbicide do you put in the tank? 15 quarts. That's good. Another bonus question. How many gallons is 15 quarts? All right. 3.75. 4 quarts a gallon, so you divide 15 by 4, you get 3.75. Have you ever seen a graduated cup in tenths of a gallon? I meant to bring mine today. Except I used it yesterday, it's still dirty. Okay? So, no, you've never seen it, all right? So here's another bonus question, I think. There's 4 quarts in a gallon, so 15 divided by 4 is 3.75. So do you take that last quart, okay, and how do you do it? How do you work it out? All right? How many ounces in 0.75 gallons? All right. Well, you'd go back to your 128 ounces per gallon and multiply by 0.75. 96 ounces. So that's what you put in your cup. Now, my cup only measures 64 ounces at a time, so I got to put 64 in and then add the other 32. All right. Oh, why did the airboat sink? It's a 14-foot airboat with a 300-gallon tank. You don't put 1,200 pounds of a herbicide mixture in a 14-foot fiberglass boat, ever, ever. All right. Switch horses a little bit here. Do it a little bit different. Let's go to some backpack spraying or something similar to it. Let's go to percent solutions. And this is easy. While reading a label, Gator reads that a surfactant needs to be added to the tank at 2% volume per volume. That's really high for surfactant, all right? Mostly they're what? 0.25 to 0.5%. But let's just use 2%. That's what the question asks. This tank is 300 gallons. How many gallons of surfactant does Gator need to add to the tank? So you always put your herbicide in, or your water in first, your diluent. Then you add your herbicide. Then you add the surfactant you need. Then you top it off with water. So for 300 gallons of tank mix, total tank mix, what's 2%? How much surfactant would you put in there? Pretty easy, isn't it? Yeah. 6 gallons. Because 2% is like 2 gallons in 100. Okay, it's really 2 in 98. All right? All right? So you can answer without a calculator. But I'm going to tell you a secret. All right? Always, always, always move the decimal for percent 2 places to the left and multiply. Because what if you had 222.5 gallons in that tank? You wouldn't have any clue by doing it in your head. This is close enough. You know, no, that isn't the way it works. It doesn't work that way in the exam. You move over 2 places, because percent is parts of 100. So you move over 2 places. So it's 0.02 times 300 gallons is 6 gallons of surfactant. It'll give you the right answer no matter what you're dealing with. Whether it's a backpack sprayer, whether it's a quart sprayer, It'll tell you what you need as long as you're working in the same units, all right? So always move the decimal 2 places left, and it'll give you how much material you have to add. We'll get more of this in a little bit. All right. All right, here's another canal. It's along the road here. It's 15 feet wide. All right. Gator decides to read the question, decides to determine the speed of his new boat. If his spray width is 15 feet wide, okay, he's going to spray 15 feet wide, that's the whole canal, while moving forward at a rate of 80 feet every 35 seconds. All right. What is Gator's speed in feet per minute? Wait a minute. It's 15 feet wide, and he's going, there's something in here we don't even need. What's the question ask? The question asks, what's his speed in feet per minute? Doesn't have anything to do with swath width. So what do we call that? That's a red herring. Love to put those in exams. Love to have a student out there trying to figure out how that 15 goes in that equation to figure out how many feet he's going in a minute. It can't be done. It has nothing to do with it. But boy, is it fun to do. All right? So it's a red herring. So you got to read the question. What does it ask? It says, what is Gator's speed in feet per minute? In calibration tests and questions, there's always more than one way to skin a cat. All right? I don't follow the formulas. I try to think of what I need and what information is given to get the answer. Now, a lot of people use formulas, but I found in about 25, 30 years of doing this that if a person looks at a formula and starts plugging numbers in it, they really don't know what they're doing unless they really know what they're doing. All right? So I don't use and follow formulas a whole lot. There are formulas in the book that you can use, but I think you can use your head to figure out what's going on here. All right, enough of that preaching, all right? You're moving 80 feet every 35 seconds. What is Gator's speed in feet per minute? Three different ways you can get it, but here's what I like to do is I'm pretty sure I divided 80 by 35 to get my feet per second, and then multiply by 60 seconds in a minute. See if that's what I did. Since there are 60 seconds in a minute, why not find his speed in feet per second and multiply by 60? All right? That's the way I did it. Other ways you can do it. You can take what percentage of 35 feet or seconds is of a minute and do that fraction too. But it's easy. The answer is right there. You just divide 80 feet in 35 seconds, and you get 2.285 feet per second times 60 seconds, 137 feet per minute. Now, I happen to know that 188 feet, is McDonald here? They ran out. I think 188 feet a minute is a mile per hour. So this is almost a mile per hour. But that's not the question. That's the question, and we've answered it. What is Gator's speed in feet per minute? 137 feet per minute. That's the answer. Has nothing to do with 15 feet. That's our red herring. And you'll see more in a minute. Okay. Gator's being the careful young man that he is, he decides to check the calibration of equipment. He collects 13 gallons of water during a 4-minute period. What's the output rate in gallon per minute of his new pump? Now, this is rigged up for a submerged application. It's got 4 nozzles on it. They're weighted hoses. Drop them over the side and go on along. And you know that you're doing 13 gallons in 4 minutes. So how much is your gallons per minute? Pretty straightforward. This is really similar to the question that's on the exam. 3 1/4 gallons per minute. And that's a pretty typical rate. I think the pumps I got run between 3 and 5 gallons per minute, depending on how I got it set. All right, everybody all right on that one? That's pretty easy. I went back to this crazy canal again. Gator's asked to come out and spray a canal that's 2.5 miles long. He can only spray 10 feet on each side. All right, so we know we got that previous question back in number 2 or 3. His equipment is calibrated to deliver 50 gallons per acre. How many total gallons of tank mix will Gator take to spray the canal? Okay. Well, what I have people do if they're taking an exam is I go real slow. And I said 10 feet on 2 sides is 20 feet sprayed, doing it a little bit different than I did back earlier. I remember I did 10 feet at a time. 2.5 miles times that is 13,200 feet long. All right, so 20 feet wide times 13,200 feet. 264,000 square feet divided by feet per acre, and we're going to spray an area of 6.06 acres. Probably 6.1 acres would be close enough. All right, so what's the question? How many gallons of mix will Gator take to spray the canal? So he's got this truck with a 500-gallon tank on it, and he doesn't want to overfill, because you certainly don't want to go back to the shop with 500 or 250 gallons of material with you. All right, and the boss is going to say, now what are you going to do with that? All right, so you got to get it right. So at 50 gallons per acre, 6.06 acres, you what? Multiply the two, and you're going to mix up 303 gallons. Do it exactly at the right speed on each side of the canal. The way you've calibrated it, you should go home with nothing in the sprayer. And that makes the boss real happy. Gator's got a rough week. He decides to spray a canal with a truck using a handgun. He calculates his speed along a canal bank, 200 feet per minute. All right, that's moving right along, a little over a mile an hour. His handgun will cover a 25 feet wide swath width. So this is a little different canal than we've seen before. And the handgun will discharge 4 gallons of spray per minute. What is the spray volume in gallons per acre? All right, well, it's a little more complicated, isn't it? I told you they'd get a little more complicated. This is about as difficult as it gets. All right, let's look at it again. Calculate the speed to be 200 feet per minute. His handgun will cover 25 feet wide at 4 gallons per minute. So he's doing 4 gallons per minute, and he's doing 200 feet long by 25 feet wide. So if we multiply 25 feet wide times 200, we get the area that he can spray in 1 minute, the fraction of an acre, and we know that he's doing 4 gallons spray per minute. Different ways to do that, but those are the 3 numbers you need, the only 3 numbers they gave you. Let's see how I did it. Actually, there's more than one way to do this. First of all, you know that you've got to figure out because the gallon is, the question doesn't need acres, but you got to get acres to get there. 200 feet per minute times 20 feet wide is 5,000 feet per minute. All right, that's the square feet that he's covering. And if you wanted to know how much of an acre that was, you could divide it by 43,560, but let's see how I did it. I did it that way, okay? 43,560 divided by 5,000, okay? Because I know I'm doing 5,000 feet per minute. If I divide it into 43,560, it's going to take 8.71 minutes to cover 1 acre. 8.71 minutes. All right? So we're going to do an acre. And the question is, what's the spray volume in gallons per acre? So we need that acre. So 4 gallons a minute times 8.7 minutes per acre, and we're doing about 35 gallons per acre. Okay? Different ways you can do that, but you need to come up with that answer. And it's pretty simple. You get your area sprayed per minute. You know what your gallon discharge is of your pump sprayer in 4 gallons per minute, and it's just a matter of finding out how many minutes does it take to do an acre. It's 8.7 minutes, and you multiply by 4. Gator's got a bad problem with algae in a 4-acre pond with an average depth of 7.5 feet. Don't you already know you're going to have to come up with acre feet here? He decides to use an algicide containing 3 pounds of active ingredient. It's a 3 emulsifiable concentrate per gallon. Being the great calibration expert he is, scientist reads the label, and he wants to read it at 0.5 parts per million active ingredient. And how many gallons of product does Gator need to purchase? All right. Well, 4-acre ponds times 7.5 feet deep. All right. Anything with ppm or ppb, you need the pond volume. With endothal, diquat, and copper, we're treating in the part per million range. With fluoridone, bispirabac, penoxylam, gallium, some of these we're treating in the parts per billion range. All right. And I'll show you a little bit about the big difference between that. It's a 1,000-fold difference. 1 acre foot, 2.7 million pounds of water. Remember we did that acre foot, a foot deep, 43,560 cubic feet? It weighs 2.7 million pounds. This would be easy, all right, if an acre foot of water weighed 1 million pounds. Because if you added 1 pound of salt, 1 pound of herbicide in that acre foot, you'd have a part per million. But because it's 2.7 million pounds, you've got to add 2.7 pounds per acre foot, all right? And that gives you 1 part per million. 2.7 pounds of active ingredient per acre foot is 1 part per million because an acre foot weighs 2.7 million pounds. All right? A part per billion is 1,000 times less. So 0.00, move the decimal 3 places to the left, 0.0027 pounds per AI per acre foot is 1 part per billion. Now, 10 years, 15, 20 years ago, all aquatic applicators had to figure this out for themselves. But now the companies are putting it on the label and making it clearer and clearer. So there's tables on there that you can figure this out. But everybody had to do these. And there is still on the exam one of these questions. You need 1/2 part per million in a pond, or 0.5 parts per million per acre foot. All right? Well, how much we need? Let's figure it out. The question is, how many gallons does Gator need to purchase for the whole pond? 0.5 parts per million, all right, times 2.7, all right, equals 1.35 pounds of AI per acre foot. That's what you need. You need 0.5 parts per million is half of that 2.7. Remember, 2.7 is 1 part per million. They want 1/2 part per million, so you need 1.35 pounds of active ingredient per acre foot. The volume of the lake, 4 acres, 7.5 feet deep, multiply them, is 30 acre feet, and for every one of those acre feet, you need to apply 1.35 pounds for every acre foot. So if you've got 30 acre feet, you multiply by 1.35 pounds per acre foot, and it gives you 40.5 pounds needed. Read the question. You got her down now. That's what you need. That's the active ingredient you need to treat that whole lake at 1/2 part per million of whatever it is. Gator reads the label, specifies treatment. How many gallons of products does Gator need to purchase? All right, he's got a 3 EC per gallon. Generally, when you see that, if it's a liquid, it's a 3-pound gallon of an emulsifiable concentrate. You learned that in your core exams and stuff like that. So it's 3 pounds per gallon. It's pretty easy now, isn't it? You got it, right. Divide 40.5 by 3, all right, 13.5 gallons. That's what you buy, and that's what you put in the lake. All right. Copper sulfate, some of you use that, it's a little bit different. If you use the copper sulfate pentahydrate, the blue powder, copper active ingredient is 25%. So percent's a little bit different there. But this is teaching you, this is more of an endothol type treatment, okay? It's really not hard if you kind of go through it step by step. Gator is called to treat a section of canal with a 5% pelleted herbicide at a rate of 25 pounds of pellets per acre. Canal section is 6 miles long and 40 feet wide. What's the total amount of pellets that he's going to buy and apply? It goes back to some earlier ones. Break it apart. But I see something a little fishy here. The question is, what's the total amount of pellets to be applied? 5%, that doesn't make any, it's not asking you for active ingredient. It's asking you for the formulated product. If the canal is 6 miles long and 40 feet wide, what's the total amount of pellets to be applied? So this is another red herring. All right? So basically, just thinking about it, I got to get the acres here. So I got to take 6 miles long, get my acres, and divide by 43,650 and multiply by 25. I mean, you do it step by step. Let's see what we did here. The 5% pellet herbicide has nothing to do with it. Figure out your number of feet in 6 miles. All right. Get your area by multiplying by the width of the canal, which is 40 feet. You get 1,260,200 square feet. Divide it by what? Divide it by, not acre feet, but square feet an acre. All right, 43,560 gives you 29.09 acres at 25 pounds per acre. You buy 727 pounds of material. All right, that might happen to be 5% if that's what the boss sent you to get. All right, Got another boat with a centrifugal spreader mounted on it. It wants to apply a 10% pellet herbicide at a rate of 50 pounds of pellets per acre. Gator tests his boat and determines his boat will treat 0.3 acres per minute. How many pounds must he broadcast through that spreader each minute? All right, doesn't talk about swath width. He knows what he's spreading. He wants 50 pounds per acre. The 10% is, again, irrelevant. All right, he's treating 0.3 acres at the speed he's going. So I've got to get my spreader set up, and I got to get it cranking out there. So what are we going to do? The 10% is a red herring again. 50 pounds per acre, all right, times 0.3. Okay, he's doing 0.3 acres per minute. Equal means that he wants to put out 15 pounds per minute. All right, just multiply by 0.3, because he's putting out, he gives you 50 pounds per acre, all right, in 0.3 acres per minute. So just multiply it. He's got to get through that machine 15 pounds per minute. That's a lot of pounds. Yeah. All right. Easy. All right, we'll go back to some backpack work again, I guess. Old Gator wants to do some touch-up on torpedo grass around a condo pond. This is really relevant to what you're doing. He only needs to mix up glyphosate and surfactant for 1/3 of an acre. He typically uses, when he's doing a large treatment on cattails and torpedo grass and stuff, 3 quarts of glyphosate with a 0.5% surfactant and a total mix of 60 gallons per acre. Very standard treatment. How much glyphosate, water, and surfactant should he add to his 100-gallon tank to do 1/3 acre treatment? All right. Well, let's kind of break it down. He's using 1/3 acre treatment, and you can almost do this in your head, 60 gallons per acre. So we know, let's put the math up so that we don't confuse. Okay, 1/3 or 0.33 of an acre of 3 quarts is, we're going to need 0.99 quarts or 1 quart of glyphosate. All right, we're doing 1/3 of an acre. All right, so you're using about 20 gallons of total mix, using 3 quarts of glyphosate with a 0.5% solution. So let's just get it down into 1/3. So he knows he's going to add about, the applicator knows they're going to add about 1 quart of glyphosate. He's going to use about 19.8 gallons of water in that 1/3 of an acre. Now, how much surfactant do I use? What do I do with that 0.5%? Move the decimal, what? 2 places to the left. All right. All right. But I made a mistake here. I didn't make a mistake here. Move it 2 to the left times 20 gallons of total mix is 0.1 gallons, okay? 128 ounces, you're going to use a quart. 12.8 ounces, I'm sorry. 0.1 gallons times 128 is 12.8 ounces. So see why you move the decimal now to the left? Because you couldn't have come up with this just thinking it in your head. I just made a mistake on it, and I've done this 20 times. All right, so move the decimal 2 places to the left. Do it again. Gator wants to do a backpack work and some cattails with a 3-gallon backpack sprayer. To make a 3-gallon mix backpack, you make a 3-gallon mix of 2% glyphosate and 0.25% of surfactant. How much herbicide and how much surfactant should be added? All right, there's no tricks in here. You do this every day. 2% glyphosate. Now let's see what we did. 2% glyphosate. You see an error there? Yeah, I went too far to the left. All right, and that's bad because you're only going to use about 10% of what you need. 0.02, move the decimal 2 places. This is 2.0. Move the decimal 2 places, not 3 like I did at the top. 0.02 times 3 gallons equals 0.06 gallons. All right, but I can't measure in 0.06 gallons, so I multiply by the gallon or the fluid ounces in a gallon, and I get 7.68 ounces of glyphosate. You see how easy it is if you move that decimal 2 places to the left? All right, so I'm going to have to put in that 3-gallon tank mix 7.6 ounces of glyphosate, and you can't measure it that close anyway, so 7.7 is close enough. All right, now you move the decimal over. I want 0.25% surfactant. Move the decimal 2 places to the left, times 3 gallons is 0.0075, equals about 1 ounce of surfactant. Did you all know how to do that? Does that help? All right. So basically add the herbicide. Well, you add it half full of water, add the herbicide, add the surfactant, fill it up, and away to go. All right. Do you know how to do this, the output in gallons per minute of a boom sprayer and so forth? Yeah. Well, I don't think I'm going to be able to show you. This is a video that we did years ago, and you can buy the calibration tape from the University of Florida bookstore. Basically, what you do is you've got a sprayer, and you're putting out 4 or 5 hoses, you're dragging hoses. Put them in 5-gallon buckets and let it run for a couple of minutes, and then collect your buckets and see how, number one, uniform they are and what your total output of the pump is. And the same thing with a handgun. You take your handgun, you shoot it over towards the wall, you measure your swath width, and then shoot it into a garbage can with a plastic bag around it for 2 or 3 minutes, and you get your gallon of output that way. The other way you can do your total output is you fill the tank right to the top, and then spray for 2 minutes, and then count the number of gallons of water you put back in it to fill it to the top. So there's different ways to do it. All right. Remember, what you really need, all right, is gallons per minute output of your pump, your swath width, and your speed. That's all you need, and you can do any calibration that's ever requested of you to do. And I think that's it. See what happens here. There's your granular spreader all taped up so we can get output. Now remember, on your granular, a lot of you got, what are you using now? Grand blow mostly, the blowers? All right, well, I still use antiquated equipment. The calibration's the same, no. You can generally get some blank pellets from the manufacturer, or from Helena or Winthrop or one of the suppliers, and you can figure out what your herbicide is doing in swath width on your spreader and feet per acre, and then you got your output in pounds of product at a certain setting per minute. And that's really all you need, so it shouldn't be that hard. All right, that's it.